Hey, welcome to the channel all about civil engineering. This lecture is about relationship between shear force and bending moment. I guess all of us are known about the popular relation. Rate of change of bending moment is equal to shear force. That is, the first derivative of bending moment is equal to shear force. Today I am gonna cover that how this relation holds true, showing its mathematical derivation. First of all, let us consider a simply supported beam of span L that is carrying uniformly distributed load of intensity W kN per meter. So in this beam, two reactions are unknown, that is Ra and Rb. These two reactions are unknown. So let us begin with the calculation of Ra and Rb, which are acting in upward directions. To calculate the reaction at point B, I am going to use static equilibrium, that is summation of moment at A is equal to 0. Since the reaction at B, that is Rb, rotates the beam, this Rb rotates the beam in anti-clockwise direction. So it is taken as negative. Similarly, the UDL acting on the beam gonna rotate the beam in clockwise direction, so it is taken as positive since our considered direction is positive for clockwise. On calculation, we obtain the value of Rb as WL by 2. To calculate another unknown, that is Ra, I am going to use the static equilibrium equation, summation of f of y is equal to 0, considering upward forces positive. Ra and Rb are acting in upward direction, so it is taken as positive. These two reactions are taken as positive since Ra and Rb are in upward directions. And this UDL, W kN per meter, is acting in downward direction, so it is taken as negative. On calculation, we obtain the value of Ra as WL by 2. Now, let us consider a section XX at distance x from the left end, that is from point A. Sign convention for the calculation of shear force is shown in this figure. As we move from right to left on the beam, all the downward forces are taken as positive and all the upward forces are taken as negative. Similarly, if we move from left to right on the beam, all the upward forces are taken as positive and all the downward forces are taken as negative. So, considering this sign convention, I am gonna calculate the shear force at section XX. I am gonna move from left to right on the beam. So using this sign convention, Ra is in upward direction, so it is taken as positive since this Ra is in upward direction. And the load W kN per meter, which is over the span of x, is in downward direction, so it is taken as negative. The value of shear force at section XX comes out to be W times of L divided by 2 minus W times of x. Let us consider it as equation first. Now let us calculate the bending moment at section XX. The sign convention for bending moment is shown in this figure. The sign convention for sagging moment is taken as positive and for hugging moment is taken as negative. Using this sign convention, I am gonna calculate bending moment at section XX. Given beam is this, so we are observing the bending moment at section XX. This force Ra tends to rotate the beam in clockwise direction, and the deflected shape would be somehow like this, as shown in the figure. So the reflected shape, this is the case of sagging moment, and For the moment due to reaction Ra, due to reaction Ra, this reaction is taken as positive. Similarly, another load of W kN per meter over the span of X is acting on the left of the section XX. So, the bending moment generated by this load has the deflected shape somehow like this, which resembles with the sign convention of hogging moment. So it is taken as negative. So here we can see that the bending moment at section XX is equal to Ra times of X minus W times of X divided by 2. On calculation, we obtain the value of bending moment as W times of L divided by 2 times of X minus W times of X to the power 2 divided by 2. Let this equation be equation second. Now differentiating both sides with respect to X, we have the previous equation is. On differentiating, we get the value of first derivative of bending moment as W times of L divided by 2 minus W times of X. So here in equation first, we see that V is equal to WL by 2 minus W times of X, where V is the shear force, and here in equation third, we can see that dm by dx is equal to WL by 2 minus W times of X. So this WL by 2 minus W times of X is nothing but it is just a shear force. So from equation first and from equation third, we can write as first derivative of bending moment is equal to shear force, that is the rate of change of bending moment is equal to the shear force, and this is our required relation between the bending moment and shear force. So this was the lecture on relationship between shear force and bending moment. Only this much for today. I will be right back with new video lecture. Till then, take care and have a good time ahead. Keep studying and keep learning.